Hello, fourth graders. Here is a answer key for today's homework, just in case you aren't able to make it to math workshop today. So as we can see here, starting off with number one, it says a small tree frog jumped 170 millimeters. So we have 1 unit of millimeters. A bullfrog jumped 129 millimeters. So we have another millimeter measurement. How much farther did the tree frog jump? Okay, so our question is asking us how much farther did the tree frog jump? It's not asking us to convert anything yet, which is nice. So essentially, all we have to do is, it's asking us how much farther. Well, the tree frog jumped 170 millimeters, and I'm going to draw an MM because that represents millimeters. And then I'm going to subtract 129 to find that difference between the two. I'm going to draw millimeters again for my units. And when I go ahead and do that, 170 minus 129, what is that? We get our answer of 41 millimeters. Now remember to always write your units here. And one thing that can be interesting about these problems and why it's so important that you write your units is so that you don't get confused. Because when you're going from one unit to another unit, if you have a number that's written down that doesn't have a unit, we don't know if we're going from one thing to another. We have no idea. So that's why it's super important that you're using these labels to label your units. So going on to number 2, it says Asia has 13 kilograms of apples. Sophia has 6 times as many kilograms of apples as Asia. How many kilograms of apples does Sophia have? Okay, so we have 13 kilograms. Then Sophia has 6 times as many kilograms. So then the question is asking us, how many kilograms of apples does Sophia have? So we're not changing any measurements here. We're going to go ahead and we are going to figure this out. So 13 kilograms of apples. So we're going to fill out 13 kilograms. And a kilogram, you can write kg. Like the K represents the kilo and the G represents the gram, so kilogram. Then if we say Sophia has 6 times as many, well, we're going to then multiply that by 6. And we don't need to write a unit there because we are just multiplying it by 6. So when we do 13 times 6, what we get is, we get 78. So we're going to go ahead and write down 78. So it's going to be 78. It's not going to be 78 apples, though. It's going to be 78 kilograms of apples. So that is our problem there. All right. Those are our 2 answers so far. Move on to the next slide here. It says, Juan has 9 liters of lemonade to share with 5 of his friends. If the 6 kids share all of the lemonade evenly, how many milliliters of lemonade will each one of them get? Okay, so now we have our first problem where we start with 9 liters across 6 kids, and the question is asking us, how many milliliters of lemonade will we get? So because we are changing the units, I think let's go back to our chart here and let's review this really quick. This chart is here for any of you if you need it. It's always good to go back and review stuff in case you forget. So what we started with, it said 9 liters of lemonade. And since we're going from liters to milliliters, what I want to do is I'm going to go ahead and I'm going to take a look at our volume chart here. So for every 1 liter, there is 1,000 milliliters. Okay, that's a good thing to know. So then for 1 liter equals 1,000 milliliters. So then that means that if I have 9 liters, I can multiply that by 1,000 to equal 9, having 9 liters. That would be like if I drew 9 here, 9 liters would not equal 1,000 milliliters. Each liter contains 1,000. So 9 liters multiplied by 1,000 is going to give us our amount of total lemonade. So which will be 9,000 milliliters of lemonade. Now, that's how much we have in total. This is again why it's super important that we read the whole problem. If the 6 kids share all of the lemonade evenly, how many milliliters of lemonade will each of them get? Okay, so that means that we're going to have to divide this, or I can write it like this. We're going to have to divide this by 6. So go ahead and try to figure that out. What is going to be 9,000 times 6, or divided by 6, sorry. One strategy I use to figure out what 9,000 divided by 6 is I use a strategy where I'm starting almost like long division. So I'm dividing 6, and I'm going to see how many times can 6 go into 9. Well, that goes into there 1 time, and when I multiply that out, 6, I'm left over with 3. So then, because I have 3 is half of 6. So that means that I have 0.5. So if 6 goes into 9 1.5 times, that means that if I multiply 1.5 times 6, actually, I'm thinking something wrong. I'm so sorry. I explained that a little bit wrong. So let's go back to this step here. I have 6, and I have a 0 here because I have a decimal point. So I'm going to bring that decimal point down. 30. How many times does 6 go into 30? Is 5 times. So then if you just continue adding zeros, and just imagine that this is 9,000. I'm going to go back. Imagine that this is just 9,000. So then what you're thinking is you can add 2 zeros on the back of it to get our total of 1,500 milliliters. So that is our answer here. And I'm going to go ahead and I'm going to circle that in pink to represent that that's my answer. Okay, going on to the next problem. It says, Chris, Darren, and Evan brought water to share with their teammates at the school game. Chris brought 13 liters of water. I'm going to highlight that. Darren brought 950 milliliters of water. Okay, there's 950 milliliters of water. Evan brought 1,500 milliliters of water. How many milliliters did they bring in all? So we're going to have to be adding 13 liters plus 950 milliliters plus 1,500 milliliters. So before we can add these all up, though, we do not have them all as the same unit. We need to change this 13 into milliliters so that it matches the rest of our problem. So let's go ahead and take a look back at our liters. All right, well, remember, we have for every 1 liter, there's 1,000 milliliters. So that means that I can take 1 liter or I can take actually, sorry, not 1 liter. I meant 13 liters, and I can multiply it by 1,000. When I do that, I get my total of 13,000. So 13,000 liters plus 950 milliliters plus 1,500 milliliters. So when we add them all together, let's see what we get. Go ahead, pause right now. Let's see what you get. We get our total of 15,450. And it's going to be milliliters. And we have our last problem for today. Nia has 1 liter container of juice. Okay, has a 1 liter container of juice. She drank 356 milliliters, and then she drank 278 milliliters. How many milliliters of juice does Nia have left? Okay, so if she drank this amount, 356 milliliters and 278 milliliters, I'm thinking in my head, I could probably add those together before we get into it. So let's add 356 plus 278. So when we do that, 356 plus 278. When we do that, 8 plus 6 equals, it equals 14. Carry the 1. 7 plus 5 equals 7 plus 5 equals 12, plus 1 equals 13. And then 3 plus 2 is 5, plus 1 is 6. So our total right now is at 643, or 634, I read that wrong, 634 milliliters. And it says she had a 1 liter container of juice. So if she had a container of juice and she drank from it, and we're trying to figure out how much is left, we could subtract how much she drank from the container. So remember, let's think though, 1 liter has how many milliliters? 1,000. So 1,000 minus 634. When I take 1,000 and I subtract 634, I get my total of 366 milliliters left. So these are all of the answers to our assignment today. So if you have any questions, still feel free to join our math workshop. Otherwise, I hope that this worked well for you. Otherwise, you can have a great rest of your day. Remember that this is where you can post a picture of your Number Corner workbook if you didn't do the assignment virtually. So remember that once you have submitted your assignment, then you are all set for today. So thank you so much for joining me. I hope you have a great rest of your day, and I'll see you guys later. Bye, everybody.